Hi Year 12 Maths General students. This lesson is from Unit 4 of the Queensland General Maths syllabus, and today we're looking at perpetuities, or free money for life. In this lesson we're going to define what a perpetuity is within an investment scenario, and then we're going to solve problems that involve perpetuities in investment scenarios using formula that we're given, and we're also going to check with our TVM Excel calculator. In a previous lesson, we're introduced to the concept of perpetuities when we're investigating the withdrawal phase of an investment annuity. We were playing around with some spreadsheets and we put in a withdrawal payment that we saw maintained the balance of an investment. So a perpetuity is a regular withdrawal amount from an investment that's equal to the value of the interest earned after one compounding period, and the balance of the investment remains the same constant value forever. So like I was saying, free money for life. This means that the regular payment can be withdrawn for as long as required, and this does not change the balance of the investment as time progresses. So how do we find the value of a perpetuity withdrawal payment? Now, unfortunately, this formula is not on our formula sheet, so you're going to have to remember this one by heart or by brain. Now, to find the value of this perpetuity withdrawal payment, it's simply equal to the decimal interest rate multiplied by the balance of the investment. Now, this formula can be rearranged if you wanted to find other things like the balance of the investment required to sustain a given perpetuity withdrawal value. As long as you know the perpetuity withdrawal amount, you would divide that by the decimal interest rate. You can also determine the decimal interest rate required to sustain a given investment balance, withdrawing a certain amount of money as a perpetuity. So rearranging the formula again for I, that's simply the withdrawal amount as a perpetuity divided by the investment balance. Alright, so let's try some examples to see how this formula can work. I've included a copy of the TVM calculator and investments payment schedule calculator in the description underneath this video if you'd like to download a copy and use it yourself. I've got three examples here that we're going to work through. The first is looking at a school scholarship program. We've invested $50,000 into a perpetuity which earns 7.5% per annum interest compounding quarterly. The interest earned makes up the annual scholarship prize awarded to one student attending the school for each term of the year. So they get that on a quarterly basis. Determine the value of the student scholarship to the nearest cent taken as quarterly withdrawals. Okay, the first thing I'll do is always highlight the important information within the question just by annotating. So our 50,000 is our balance that we're drawing the perpetuity from. We've got 7.5% interest compounding quarterly, so our K value is 4. I would always write down my facts down the side before I progress with the question. Remember that we need to convert our interest rate to the interest decimal rate. So that's just taking interest rate and dividing it by 100 by 4 compounding periods per year, which gives us 0.01875. Now recall the formula for a perpetuity amount is simply the decimal interest rate times the balance of the investment. So if I just simply pop my known values into my formula and evaluate, that gives me regular withdrawal perpetuity amounts of $937.50. Now if I'd like to check that on my TVM calculator for compounding periods per year, we're just going to look at a year's worth because it doesn't matter with time with perpetuities. Interest rate 7.5%. We're going to calculate the repayment. The present value is the 50,000 of the investment. We don't want that to change in the future. So we also keep that as 50,000. And remember, with this calculator, investments always have a negative value. When I hit calculate, it agrees with my answer of $937.50, and you'll notice that's negative as well because I'm withdrawing or taking it out of the account. And you can see that it won't be affected by time, so if I change that to 2 years, won't affect it. 10 years, it won't affect the repayments because it's a perpetuity. If you decided to use the investment payment schedule spreadsheet to check as well, that would also be viable. I'll just show you how you can do that. So our original principal is 50,000. We'll just leave it at 5 years because we know that time won't affect it. We've got 7.5% per annum, 4 times a year. Withdrawal payments of $937.50 starting at Q1. And you can see that the balance doesn't change. The graph shows you the balance stays constant. And you can see the payment is equal to the interest earned. So whichever technology, Excel, you'd like to use to check your answer, you decide. So I just documented what I saw there with using my 2 Excel calculators to check my answer. Moving on to question 2, we need to determine how much money needs to be invested into a perpetuity investment account if $250 needs to be withdrawn every month and the account earns interest of 5.1% per annum compounding monthly. Okay, so $250 is our perpetuity withdrawal payment. Monthly means our K value is 12. That means we need to convert our interest rate of 5.1% into the monthly decimal interest rate. And then if we know our perpetuity is the interest by the investment amount, because we're finding the investment amount, we can rearrange that formula to find the investment amount and then substitute in what we know about our perpetuity repayment divided by our monthly interest. And that gives us a balance in the account of $58,823.53 that needs to be invested if we're going to remove that payment of $250 as a perpetuity. And this one's a little bit trickier. We'll keep it to the 1 year, 12 compounding months per year. We've got a 5.1% per annum. Now for this one here, we can't, because of the way that I've coded the cells, I can't calculate the present value or future value. I just couldn't figure out how to do that. So the way I'm using the TVM calculator to check this is enter in the answer I found, which was $58,823.53 as both the present and future value. And then check that the repayment value that it spits out is the $250, which it is. So I know that my answer is correct. Okay, so I would just document that. Last question is a complex familiar. So there's going to be a couple of steps in this one. Sally sets up an investment account by investing $4,000 into an account that earns 4.3% per annum compounding monthly, and she makes regular deposits of $2,000 a month over 15 years. After this period of time, she then decides she wants to use the account as a perpetuity. Determine what withdrawal payment she will be able to make. Okay, so processing this question, it looks like we're dealing with 2 phases. So the first phase is a deposit phase where she's invested $4,000 and she's continuing to grow her money by also putting in regular deposits of $2,000 a month over this first 15 years. After this time, then she'll go into the perpetuity withdrawal phase. So to begin with, we need to find the balance in the account after 15 years. Considering a formula we've looked at before, when we're trying to calculate the future balance of a deposit phase, we're going to use this to calculate what the balance is going to be in our account after 15 years. Alright, so after writing down my facts, I know that we've got compounding periods of monthly over 15 years, so that means the total number of compounding periods is 180. Deposits are $2,000. The decimal interest rate is 0.003583 recurring. However, we'll have to round this to use it. Once I substitute all the values in, remember we end up with this fairly complicated calculation to make, and my advice was just do a little bit at a time. So calculate the inner brackets, put it to the power of 180, and you'll end up with 1.9325. You do the same with this big awful looking bracketed expression over here. Then once you evaluate the 1 added to the decimal interest rate, take that to the power of 180 minus 1, you'll end up with 0.9038, which you simply divide by the decimal interest rate, giving you $252.22. Then when you evaluate that whole next line, you should end up with a balance after 15 years of $512,218.38. That with our calculator, so we've got 180 for the 15 years of compounding periods, given there's 12 compounding periods per year, annual interest rate of 4.3%. We know she puts contributions of $2,000 per month. Because she's putting it into the bank, that's going to be registered as positive in the calculator. The present value she invested, so it's in the bank invested, so it's a negative 4,000. And we calculate the future value, which agrees with what we found using the formula. And you'll notice, because we did a bit of rounding in our calculations using the formula, there is a little bit of difference between the two values. However, that discrepancy is going to be perfectly okay in your exam responses. Okay, if we wanted to now work out the perpetuity withdrawal payment we can take out, we simply use that formula that we've learned this lesson, and that's just taking the decimal interest rate and multiplying it by the balance that we want to maintain. So substituting those values in, I end up with a perpetuity of $1,835.28 that could be withdrawn per month. So to check that, I'd simply just change the present value to match the future value and calculate the repayment. If you're worried about time affecting it, even if you change the time, it would not affect the payment value because you're maintaining the balance no matter how much time's passed. Okay, so again, we have a tiny little bit of a rounding error, but that's completely acceptable. Okay, time to try some examples for yourself. So I've put two simple familiar, a complex familiar, and a complex unfamiliar question there. So press pause, have a go at these questions, should take you 30 to 40 minutes. And then when you're done, unpause it and I'll go through my solutions and hopefully yours will match mine. Okay, how did you go? Let's look at the first question. We've got good old Davo. He wants to set up a perpetuity, and considering he invests $35,000 that pays interest of 4.8% per annum compounding monthly, we need to figure out the monthly payments he could withdraw. So we're just plugging those values into our given perpetuity formula and verifying with the TVM calculator that he could take out $140 every month in order to maintain that balance indefinitely. For question 5, we've got a local university awarding an annual scholarship prize of $5,000 using interest. So that means the $5,000 is the perpetuity amount for an investment of $80,000. Our job was to determine the annual interest rate. So we just had to simply rearrange that perpetuities formula given our known values of the balance and the perpetuity amount itself. Annually means compounding once. So once we substitute those values in, we get a decimal interest rate of 0.0625, which we simply just need to convert back to our percentage interest rate. And you should have ended up with a 6.25% per annum interest rate confirmed with the TVM calculator. Question 6 was similar to question 3 in the example that I gave you. We've got Bob, our friend Bob, who set up an investment of $65,000. He builds that investment up over 10 years by making regular quarterly payments of $6,000. If the interest rate on the account was 5.3% per annum compounding quarterly, we have to figure out the quarterly withdrawal payments he could get if he wanted the account to work as a perpetuity after the 10 years. So after thinking about the fact that we've got two phases here, we need to know the balance after the 10 years in the deposit phase. So again, we'll use that future balance deposit phase formula to work that out. After you substitute in all the values and very carefully evaluate the answer, remember doing a little bit at a time in your calculator, working from the inside of the brackets outwards. You should have ended up with a balance of the account after 10 years of $423,856.32. And you'll notice when you check with the TVM calculator, you might have a bit of a discrepancy between the answers, but that's okay because it's just because of rounding. Moving on to the second part of the question, in order to find the perpetuity during the withdrawal phase, we simply just substitute in our known balance and known decimal interest rate, and that gives us a perpetuity for Bob of $5,616.10 that it could make every month in order to maintain that balance over time. Okay, last question. Hopefully you saw through the pathway to get to the answer. So we've got an amount of money that Donna is looking at investing. Given that the amount is going to be left to grow an investment account over 5 years, interest rate 3.9% per annum, compounding quarterly. After this period of time, she wants to use the 5-year balance that could be used as a perpetuity with payments of $487.50. So we need to work backwards here, and to progress we need to think about what amount is there going to be in the account after 5 years, given that we're drawing a perpetuity of $487.50. So if we work backwards using the formula, chasing the balance amount where I could take out $487.50 at that interest rate. So if I rearrange the formula, sub those values in, I should have found out that the amount in the account was $50,000 after 5 years of saving. The second half is then thinking about, well, I need to work backwards using the compound interest formula, because if I know how much was in the account at the end of the 5 years, I can use the compound interest formula to work out how much was invested in the account in the first place. Considering that 5 years is 20 compounding periods at that decimal interest rate, I simply sub in my known values and I'm solving for P, or the initial investment. So then if I evaluate the brackets, then next step I divide by the 1.2142, I end up with a principal or initial amount of $41,179.38. that would need to be invested. All right, that's it from me. Time to go away and practice questions from your practice sets now. So hopefully that gives you a bit more confidence with understanding how perpetuities work and how you can find them. And I think that wraps up our finance unit for Unit 4. Happy studying. Thanks, Year 12s.